So welcome back everyone. In this video we will talk about first order nonlinear ODE solution method using finite difference method. So I'm giving you one statement, that is explicit formulation for non-linear ODE is similar to that of linear ODEs. Second statement is that implicit and Crank-Nicolson formulations are taken care of either by linearization or Newton-Raphson iterations. So I will explain that how linearization or Newton-Raphson iterative approach help in solving nonlinear ODE. So first remember that what is linearization. Linearization is nothing but, suppose I want to do linearization of root of x, that will be equal to root of x naught plus 1 upon 2 root x naught x minus x naught. So linearization form of function f of x is nothing but f of x naught plus x minus x naught f prime x naught. So this is my linearized form. So there's no better way than understanding this problem by giving you an example. So I'll start with an example, that is example number 1. So suppose I have an ODE that is dh over dt plus c root h is equal to f of t with initial condition h of 0, h is equal to capital. So this kind of ODEs appear when we solve problems such as tank filling or emptying of a tank. So let us first write down the explicit part, that is nothing but hn plus 1 minus hn divided by delta t plus c root hn is equal to f of tn. So my h of n plus 1 will become h of n plus delta t minus c root hn plus f of t to the power n. So this is a very simplified formulation since we know the value of hn at time n and function value at time tn. So directly we can calculate the hn plus 1. Now let us come to implicit formulation. So implicit formulation says that hn plus 1 minus hn divided by delta t would be nothing but minus c root hn plus 1 plus f of t to the power n. Now here the problem is that we cannot combine this hn plus 1 with this hn plus 1. So there is no way. So my expression is that I have hn plus 1 is equal to hn minus c delta t root of hn plus 1 plus f of t n plus 1. So by no means I can combine this hn plus 1 with this hn plus 1 to find out the formula for hn plus 1. So the direct solution of hn plus 1 does not exist. So what we will do, the first approach is that, so we need to solve this equation. So first approach is Newton-Raphson iteration. So what I will do, I want to find out the solution of this equation hn minus c delta t root of hn plus 1 plus f t n plus 1, where this hn plus 1 which is unknown, I can assume it as x. So my equation will become x plus hn minus c delta t root x plus f of t n plus 1. So this implies that I have f of hn plus 1 is equal to hn plus 1. So this is minus hn minus c delta t root of hn plus 1 plus f t to the power n plus 1, and I want to find out the solution of this f of hn plus 1, or this is equivalent to f of x is equal to x minus hn minus c delta t root x plus f of t to the power n plus 1. So at every time step I have this equation that needs to be solved, and this equation is nothing but a root finding problem. So the solution is that, x new is equal to x old minus function x old minus function value x old, or hn plus 1 new will become hn plus 1 old minus function hn plus 1 old divided by f prime hn plus 1 old. So here what we will do, first we will assume hn plus 1, and that is equivalent to hn. We will find out the hn plus 1 new using this formula, then check for convergence. If no, then my hn plus 1 old will become hn plus 1 new, and I will directly jump from here to here. Here this is my h old. So this is an iterative scheme. With this iterative scheme, we will calculate the hn plus 1 new. Here remember that my function f of hn plus 1 is nothing but hn plus 1 minus hn minus delta t minus c root hn plus 1 plus f of t n plus 1, since we are trying to find out the solution for this. Now let us come to the second part, that is using linearization approach. So that is using linearization approach, that is nothing but, so I have this hn plus 1 minus hn divided by delta t is minus c root hn plus 1 plus ft n plus 1. So write down hn plus 1 is equal to root of h tilde plus 1 upon root of h tilde, where h tilde is my h naught, hn plus 1 minus h tilde. So this will make my equation as hn plus 1 minus hn minus delta t c root of h tilde plus 1 upon 2 root h tilde hn plus 1 minus root of h tilde divided by 2 plus f of t n plus 1. So this gives me that my h of n plus 1 will be 1 plus c delta t upon 2 root h tilde is equal to h of n plus delta t minus c root h tilde upon 2 plus f of t n plus 1. This implies I have an expression for the hn plus 1 is equal to hn plus delta t minus c root h tilde divided by 2 plus f of t n plus 1 divided by 1 plus c delta t root of h tilde, 2 root of h tilde. So remember what we will do. This is like a Picard iteration type of approach.